Hello everyone, in this video I'll be explaining you the problem MEX partition. So it was asked in Codeforces Round 1058 for division 2, and yeah, let's read out the problem. Let a partition of multiset B be a collection of multisets S1, S2 up till Sk such that each element appears the same number of times in B and across all S1, S2 and Sk. So for example, some partition, let's say we have 1 2 3 3. So we can make S1 as 1 3, S2 as 2 3. So if you sum these elements, I mean take it, so it is going to be like 1 2 3 3, so which is including all the elements. And the other partition, what you can see is one more partition is like the same set 1 2 3 3 is taken, and the third set what you can take is 2 you can take, and then 1 3 you can take, and 1 3 3. So if you take here the elements, you have 1 2 3 3. So don't worry, I'll be telling you in board also. But this is not the case, because here if you take all the elements you just have 1 2 3. But if you see the original set has 1 2 3 3, so 3 is occurred only one times. So a partition is called valid if the MEX of all the multisets is the partition in the partition is same. Okay, so if you take these partitions, right, so all the MEX of all the partition has to be same. What is MEX? I'll be telling you, don't worry. So the score of a valid partition is the MEX of any multiset in the partition. So the score is basically the MEX of any multiset. Since all multisets will have the same MEX value, so we'll have to return the MEX. So you are given a multiset A of size n. Find the minimum score, okay, over all valid partitions of A. So yeah, this is they have asked in the question. So what is MEX? The minimum excluded MEX definition is basically, I mean, MEX is abbreviated form of minimum excluded. So it is basically a collection of integers C1, C2 up till Ck is defined as the smallest non-negative integer x which does not occur in the collection C. So yeah, input the given test cases, and then we have integer n denoting what is this? This is basically the multisets, how many elements will it contain, and then we have n elements. So okay, and they have said it is not guaranteed that the elements are not in non-decreasing order. So that is fine, not an issue. So what we are going to do is now, let's say like they've given two examples. In the first example we have 3 and all the elements are 0. So let's understand this problem. So in the first example n is 3 and elements in the sets are 3 elements they have given, which is 0 0 0. So out of this we'll have to make multi-set. So let me call as A. So so we'll have to make the set in such a way that we'll have to find the MEX. So I'll be telling what they're saying. So they'll give n, basically the length of how many elements in the multiset. They'll give n, I mean number of elements in multiset, you can say number of elements in multiset. This is basically an n, and in the next line they'll give n integers, which is basically, let's say, a1 a2 up till so on an. They'll give these integers. So now what they're asking is, so you'll have to make these elements in a set which is basically s1 s2 up till so on sk. You can put these elements in a set in such a way that like in the question they have given, what they've given is like whatever this element you have, these elements will occur, the frequency of particular element will be same as the frequency of all other elements. Let's say 1, if you take 1 will be, let's say, occur 2 times. So you will have if you have 2 will also be 2 times. It will not be the case this one, like 1 you have 2 times and 2 as 1 time. So this is not the case. Like in the example only they have said the frequency of all the elements will be same, that they have said. So okay, so if that is the case, now what you are going to do is, so whenever you put some elements in s1 s2 this type of sets, so in these sets you will be having element, let's say a1 a2. okay, in this, let's say you have a3 a4, a5, right? In this you can say let's say n minus 2, an minus 1, an, these elements here, let's say. So now you'll have to find the MEX of this set. You'll have to find the MEX of this set. You'll have to do the same with this also, I mean S2 also. And you'll have to do with all other sets. These are not sets, these are multi-sets, because in these sets 2 can occur 2 times, but in multi-sets one can occur 2 times, but in case of set one can occur only 1 time. So all these sets, if you find the MEX, so the MEX has to be same, they're asking. You will have to arrange in such a way that these elements you're putting in, and MEX of all these sets will be same, and the minimum MEX whatever you have, that you are going to redone. So this is the question, I mean, they have asked. So now if you take this as the elements, and let's say you do in a partition such a way that s1 is equal to 0, s2 will also hold 0, s3 will also hold 0. So now if you see here, 0 has occurred 3 times, and in this particular set 0 has occurred 2 times, here also 1 time, here also 1 time, here also 1 time. So this is one of the valid arrangement. If this is valid arrangement, then what is the MEX of this? MEX, also they have said MEX is basically integer x which is greater than or equals to 0. Okay, and the element what x you are choosing, it should not be in the set. So you should choose from 0. 0 is already there. So 1, if you try to find, 1 is not there. So 1 is MEX of this operation. I mean this set, multi-set. In the same way, MEX start with 0. So 0 is already there. Next element you take 1, 1 is not there. So 1 is the MEX of this multi-set. In the same way, this also. So all these sets have MEX as 1 only, and this is one of the least possible MEX. That's why you'll have to output 1. So let's see. Yeah, 1 is the output. So now this was one of the valid operation, I mean valid arrangement. Now let me take this way. You take multi-set S1 and S2. So here if you see, all these 3 elements are put in multi-sets, and since S1 is also multi-set, this is the bigger multi-set and this is smaller multi-sets. Now in this also since it is a multi-set, 0 can occur 2 times. So MEX if you want to find, so it will start from 0. So 0 is already there, 1 is not there, so you can put 1. In the same way, this also has 1. So no matter what you do, in this case your minimum MEX is 1 only. Your minimum MEX is 1. So yeah, this is one of the valid possible arrangement. One more arrangement, let's say we are taking, what we will do is we'll basically take all the elements in this particular set only. So if you take all the elements in particular set, so here this is also a valid MEX, I mean multi-set. Now in this case 0 is already there, 1 is not there, so MEX is 1. So so here also 1 is the answer. So yeah, we are getting 1 is answer. Let's try to take the second example, wherein we have NS2, we have 2 elements, and in a broad multiset the elements are 1, 2. Now the question is you'll have to find the sets. So if you observe keenly, what you can do is whatever set you'll be taking, put all this whatever multi-set bigger multi-set you have, or put all the elements of that in only one subset, sub multi-set, right? If you put all the elements in one multi-set, what will happen is all the element you will find in here only, and if you try to find the MEX operation of this, so this is going to be MEX will start with 0. Since 0 is not there, so 0 is the answer for this. Why I'll be putting here is that it may happen you'll have to find valid arrangements, like if you are taking S1, S2, these things, right? So if you're taking that one, let's say one of the possible arrangement if you're taking, so in this case what will happen is your MEX is 0 only. Here also your MEX is 0. So like the 0 element, whatever it is starting from, I mean MEX starts with 0. If that element is not there in this, whatever arrangement you will do, you will get 0 as the MEX. What I'm trying to say is that let's say now in your set you have 1, I mean 0 and 1 you have. If you have 0 and 1, now what will happen? So if you take this only as the one of the set, so your here MEX is going to be 0 is already there, 1 is not there, so 1 is your MEX for this. The other valid arrangement I'll take is, let's say I'm taking 0 and let's say I'm taking here 2. This is also one of the valid arrangement. So here MEX is 1 because 0 is already there, 1 is not there. Here 0 is not there, so your MEX is 0. So this is not a valid arrangement. So in order to make valid arrangement, so that valid arrangement you can find it, but it is hectic to find how to do it. But if you try to put all the elements in just single element a set of this particular multiset in just one sub multiset, so that will also be a valid arrangement, because all the elements whatever you have, that will be present in here, and it is going to hold all the conditions, which is saying like the MEX of all the set has to be same. Since we are taking only one subset, so its MEX value whatever you will get, and that is going to be only one, I mean since you have only one subset, so sub multiset, so in that case your MEX will be same only, because you don't have multiple multisets, so that's why. And in order to find minimum, so again whatever the minimum element in this multiset you will have, that will be present in if you do these type of operation, it will be present in somewhere in some of the multisets. So if it is present in some of the multisets, so that smallest element will define the MEX of the entire multiset. So that is the reason what we will be doing is, we will be taking the whatever multisets they have given, just put all the elements in your multiset, and just try to find the MEX operation of that. So you can put in multiset or you can put in set as well. So basically whatever element they'll give, put in a set. If you, let's say this were the elements that they are given. If your a value n is 4 and your a is 0 1 2 3 4, so now you will be taking S1 as one of the partition, and trivially you'll have to take the entire thing only, as I said previously. So in this case, if it find MEX will start from 0, so let's say you have still 2 3 as well. Even if you have 2 3, it doesn't matter. Your S1 I mean in my problem S1 I'll be taking it as set only, so I have 0 1 2 3 as unique elements. Your MEX starts with 0, 0 is already there, you'll go to next element, it is already there. You'll go to next element, it is already there. You'll go to next element, it is also there. You'll go to next element, which is not there. So this is your MEX of this multiset. So I think you are getting so basically whatever elements you are getting, just put in a set, and that will hold all the unique values. And you start one of the variable, let's say take MEX and start with 0, and try to find if that MEX is there in the set or not. If it is there, then you move to the next. If it is not there, then that is your minimum MEX. So let's try to code it up. So actually this was accepted during contest. Now I can't submit this code, but let me code in front of you guys. So what will happen is, let's say n as they've given test cases have taken care of this question, and we have n, the size of the multiset, and we have these many elements. So I'll not be taking in a vector or something like that, I'll be taking in a set, and I'll be using the ordered set, because MEX operation when we are doing, that will start from 0 and it is going in order, like it is finding if 0 is there, if it is finding if 1 is there, if 2 is there, if 3 is there, that way. So I'll be taking in a set only, and I'll take one variable temp, and I'll take the inputs in temp and I'll insert in the set. For set, let me call st. What is happening? Yeah, so I'll take one variable MEX, which will be 0. I mean, obviously, like MEX start from 0. I'll try to find if this MEX is present in the set, then I'll have to move to the next element, because MEX starts from 0 and the element which are not present in set, that is the MEX. And once we come out of the come out of the while loop, we'll have MEX. So let's try to run it. It is running fine, and right now I can't submit here, but if I try to code it, I mean submit this solution, it is going to accept. So yeah, thank you guys for watching the video.